Okay, so the shot put competition at the School Athletics Carnival. It is determined that the distance in X meters that the shot put can be thrown is a continuous random variable X with the probability density function defined as below. Show that the mean distance thrown is 4.5 meters, determine the standard deviation for the distance thrown, and determine the probability that X is greater than 2 given that X is less than 4. So, these are the formulas that we're going to be using for this because they've defined it as a continuous random variable. Once you find the formulas, it's really quite an easy question. So let's get started. Now, first thing I'm going to do is I'm going to state the formula for the mean. Our mean, or the expected value of X, can be expressed as multiplying between these two times it by X. Now, this is the one that everybody misses. Times the function by X dx. Now, these two are given by this one and this one. So now we're going to express our function, but we're going to substitute into it. So it's going to be equal to the integral from 0 to 12 of our function times X like that with respect to X. And then I'm just going to throw this straight in the calculator. So options, calc, the integral of X bracket 1 over 1152 bracket 144 minus X to the power of 2 bracket between 0 all the way up to 12. Execute, and we get that answer. So that is the answer of 9 over 2 meters, or we could say that's 4.5 meters. Because it's tech active, we can't give you marks anywhere else. Next thing we're going to do is determine the standard deviation for the distance thrown. So standard deviation is given by the square root of the variance. So we have to calculate variance first. Now, to do that, we're going to apply this formula, which isn't one that we've been using in class because the textbook's slightly different, but it's just as easy. This value here is the mean, which is that. So we're going to do exactly what the formula tells us to do. We're going to integrate between 0 to 12 for our function, this X minus the mean squared times our original function, with respect to X. Now this is going to give us the variance. Then we're going to square root the variance to get the standard deviation. So let's chuck that straight back in the calculator. Now I'm going to go back up and just adjust the formula slightly just to try and save myself a little bit of time. So it's going to become X minus 4.5 to the power of 2. The rest of it's going to stay the same. Execute, and I end up with 171 over 20. Now I want to take the square root of that to get the standard deviation. So shift, square root, shift, answer, execute. Now in exact form, that's going to be 3 root 95 over 10, or if I press F to D, I'll get that in a nicer form, 2.9240. Okay, so it's got a standard deviation of 2.924 meters. Okay, next one that we're going to do is the probability that it is greater than 2 given that it's less than 4. So we're going to scroll down for this one. We're going to look at our statements. Now, you are actually given a formula for your given statements. Now, the formula that you get is this one. Okay, so it's not a hard one to remember. It comes up every now and again. There it is. Okay, so in order for us to do this question, it is the probability that X is greater than 2 given that X is less than 4. Now, on the top, that means that we're only including the values that makes this statement true. So we're looking for the probability that x is between 2 and 4. And on the denominator, we're only looking at the groups where x is less than 4. So in order to determine this statement, I'm going to integrate my function between 2 and 4, just our original function, and find out what that probability is. Then I'm going to divide it by the integral of 0 up to 4 for our function, find out what that is. Now again, I'm just going to go back up and I'm going to adjust the formula that I already have to try and save myself some time. So I can get rid of this whole front bit because we're only integrating the function. Now we'll do that. We'll do the bottom first, so between 0 and 4. That gives me an answer of 0.6938. That 8 will round up to a 9. Now we're going to find what goes on the numerator, again, by just adjusting this formula. All the way, we just want to change that 0 to a 2. There we go. All right, so then that gives me 0.2338. Now, you'll know you're right because this should always give you a number that's less on the top than it is on the bottom because it's out of the given that statement. So if it's more on the top, then that means you haven't accounted for that correctly. Oh, that's a 9. Delete 9. Okay, execute that, and that is our probability. So the probability of this is equal to 0.3369 or 33.69% chance that that's going to happen.